Okay, hello students. In these sessions, we will learn inheritance concepts in object-oriented programming. So let's begin. Inheritance is one of the most important features in object-oriented programming. Using inheritance, you can remove duplicate code and make your program well structured and easy to maintain. So then what is inheritance? Inheritance is a process by which a new class is created from another class, and this new class receives properties of the another class, the base class. This means that a general form of class can be defined first, like this one, and later more specialized version of the class may be defined it, and these specialized versions of the class inherit the properties of the general class. The properties here include member variables and member functions in the class. So let's talk more about inheritance using example. Consider a group of vehicles. If you try to create classes for motorbikes, sports cars, and trucks, there should be many aspects that are common between these vehicles. For example, they all should have common components such as engines, wheels, and brakes, and so on. And they also should have common functions as well, such as accelerating, braking, and steering. So if you define classes for these vehicles, the motorbikes, sports cars, and trucks, you need to put all the common components and functions separately for each vehicles. This will lead to redundancy in your code. For example, you need to put engine components for motorbikes, sports cars, and truck classes separately, which is not the best way of designing classes because they are duplicated. So inheritance comes here to solve this problem. Using inheritance features, you can group common properties to remove redundancy in your code. So like this graph, you put common properties of vehicles in vehicle class. Then bike, cars, buses, and trucks inherit vehicle classes so that they inherit all common properties defined in this vehicle class. Then now in these four classes, bike, cars, buses, and trucks, you don't need to redundantly put common properties of vehicles and only need to put specialized properties for each type of these vehicles. This is the inheritance. The new class, such as a bike, cars, buses, and trucks, are known as derived class. These derived class are automatically created. Not automatically. These derived class are created from another class. In this example, they are created from vehicle class, and we call this vehicle class as a base class. So bike, cars, buses, trucks are derived class, and vehicle is a base class because there is an inheritance relationship between these classes. So base class is also known as a parent class or superclass. And derived class is known as a child class or subclass. The derived class automatically has all the member variables and member functions that the base class has. This process is usually expressed by saying that the derived class inherits the member variables and member functions of the base class. And as well as these inherited properties, the derived class can have additional member functions and member variables as well. And we call parents of parent class as ancestor class and child of child class as descendant class. So far, we only discussed about inheritances using examples. So now let's study inheritance using actual code. So we will use the code example of employee classes. Assume that there are two types of employees: salaried employees and hourly employed. Salary employed and hourly employed. Regardless of salaried or hourly employees, because they are both employees, they should have some common properties. For example, both salaried and hourly employees should have names because they are a person, and they should have a social security number, the SSN. So I will define employees class and place all the common properties in this class. And then I will create salaried employees class and hourly employee class, and I will make them to inherit employee class so I can remove redundancy code. So let's first define employee class. As I explained in the previous slides, employee class contains common properties that all other types of employees have. So I will include data such as name, SSN, the social security number, and pay in this employee class. And we will not have objects of this employee class. Even though we define employee class, we will not going to create objects of the employee class because employee class is just base class. It is like interface or helper class to define more specific employee classes such as salaried or hourly employee class. So we are not going to create object for employee class. It will be just used for defining other types of employee classes. And print check member function displays the information of checks. So the definition of print check member function always changes in derived classes so that different kinds of employees can have different kinds of checks. We will talk more about redefining member functions in the following sessions. So this is the definition of the employee class. Because it is base class, the parent class for other types of employee classes, it consists of common properties. So name, SSN, and net pay are common properties of all types of employees. So the employee class has member variables name, SSN, and net pay. It also has member functions for getting and setting values for name, SSN, net pay. So there is a member functions for getting the values of these three member variables and setting the values for this member variable. And these two are the constructor for this employee class. So this is a base class. We also say this is a parent class. So we defined it base class. Now it is time to define derived class, or we also say child class, which inherits the employee class. I already explained you these concepts in previous slides. The derived class inherits all the member variables and member functions of the base class. It is done automatically. You don't need to do additional task. So derived class automatically have all member variables and member function that the base class has. In the derived class, we can redefine member function, inherited member functions. We will talk about these redefinitions in the following sessions. Let's focus on inheritance concepts in these sessions. So we will talk about redefining inherited member function in the following sessions. So how can we syntactically express the inheritance in C++? This is the syntax for expressing inheritance. You start with class keyword, just like other class definitions. Then you put subclass name followed by colon and access mode, such as public or private, and then the name of the base class. So this is the concrete example for defining derived class. Here we are defining class for hourly employee. The class name is hourly employee. And you specify the base class like this one. Colon and access mode, here this is a public, and the name of the base class. If you put this line like this one, the hourly employee class will inherit all the properties such as member variables and member functions defined in this employee class. So this is the example code for hourly employee class. So as we talked about in the previous slide, this hourly employee class inherited the employee class using this syntax. As you can see here, this class has two member variables, wage rate and hours. These members are specialized for hourly employee only, so we did not place these two member variable in the base class, which is an employee class. The definition of the class hourly employee does not mention the member variables name, SSN, and net pay, but every object of the class hourly employee has member variable named name, SSN, and net pay. Because the member variable name, SSN, net pay are inherited from the class employees. Okay, so recall that this employee class has a name, SSN, net pay member variable. So because hourly employee class inherits this employee classes, so it inherits all the member functions and member variable defined in this class. So that is the reason why hourly employee has name, SSN, and net pay member variable, even though it only defines two member variables. So every object of the class hourly employee have 5 member variables named name, SSN, net pay, which is defined here, employee class, and as well as wage rate and hours member variable. If you don't have inheritance features, you have to explicitly specify name, SSN, net pay member variable in hourly employee class here as well, which will not save you writing identical code multiple times in similar type of classes. So note that the hourly employee class did not declare the member variables or functions that inherited from employee class. So they did not, so there is no declarations for the member variable name, SSN, and net pay. But even though this hourly employee class did not declare them, you can still use them. It is automatically inherited from employee class. You don't need to do additional work for defining them. Defining the properties in the base class. But if you want to redefine the inherited members, for example, if you want to change the definitions of inherited member functions, you have to explicitly declare them. Oops, sorry. So as shown here. So for example, print check is the member functions declared in the employee class. So if you look at here, employee class declare the print check member functions. But hourly employee class also declared print check member function here because it wants to redefine its function definitions. So in summary, unless you want to redefine inherited members, you don't need to specify in the derived class. So let's look at the demo code for the inheritance features. So this is the demo code. We have two classes in this code. We have a class name person here, and then we have a class name students. This class persons consists of one member variable name, and it has 3 member functions for getting the value of name and setting the value of name and printing the name, the value of the name. And here we are defining the print info functions for this person class. It just prints the member variable name here. And student class inherits this person class. So using this syntax. So student is a derived class, child class of this person class. Person is a base class, or we also say parents class. So students class inherits all the properties defined it in the person class. So it inherits all these member functions and the member variables. And as well as inherited members, it can also additionally define member variables and member functions. So inside of these students class definitions, it defines one member variable for saving student ID, and it also defines 2 member functions for setting the value of student ID and getting the value of the student ID. Okay, so that is the students. So this is a derived class, and this is a base class, and child class, and parent class. And inside of this main function, we create the objects of the students class. We pass the name of the students. So this constructor will be called in this line. So as this constructor calls the parent class's constructor, which is this one. So the member variable name will be set to JSON. And here we call the print info member functions. These print member print info member function just prints the name of the person. But as you can see here, there is no print info member functions inside of these student class definitions. Inside of these student class definitions, it only has set SID and get SID member function. It does not have print info member function here. Do you think this leads to the compiler error because we are using students object of student class to call this print info function, but the students class doesn't have this print info member function? Do you think this leads to the compiler error? Let's compile this code and see the output. As you can see here, this does not lead to any compiler error. And if we execute the program output is this one, named JSON, because of this one. This means that we successfully call these print info member functions, even though the student class does not declare these print info member functions. This is possible because the student class inherits this person class, and because it inherits this person class, it inherits all the properties defined in this person class. So inside of this person class, there is a print info member functions. So student class inherits this print info member function defined in this person class. So that is the reason why students objects, the object of the student class, can call this print info member functions, even though it does not have even though the student class did not declare these print info member functions. It uses the member function defined in the persons class, which is a parents class. So that's the concepts of inheritance. You can use the members defined in the parents class or base class, like this one. Okay, let's go back to the slides. So we just saw this demo code. So in summary, in these sessions, we learned the inheritance concepts, and we talk about the base class, the parents class, and the derived class, child class, using employee and our employee example. The derived class, such as hourly employee, automatically receive all the member variables and member functions of the base class, such as employee class, and the derived class can also add additional member variables and member functions. Using inheritance features, we can remove identical code or duplicate code and make the program more structured and easy to maintain. Okay, so that's it for these sessions. See you in the following sessions.